If we were to build the most efficient machine possible, it would have only a single blade spinning so fast that the sky itself would blur into a knife. Yet you would never allow such a structure to rise behind your own home. That is the paradox of renewable energy. The more technically efficient something becomes, the harder it is for society to accept. Engineers see Bernoulli equations, lift forces, RPM, and performance metrics. But when people look up, they see a symbol, massive machines slicing the wind, reshaping the horizon, even occupying psychological space. A wind turbine is not merely a mechanical device. It is the physical embodiment of energy power taller than the Statue of Liberty, heavier than a Boeing aircraft, turning minute after minute to keep millions of homes illuminated. The real question is no longer how many blades are most efficient, but rather what made the entire planet converge on a three-blade form an icon that is at once technocratic and aesthetic, scientific yet deeply psychological. To understand that, we must look at the intersection between engineering and human behavior, from fear and beauty to economics and global politics. The NIMBY effect, not in my backyard, remains a classic psychological barrier in every infrastructure project. People support clean energy in principle, yet hesitate when turbines appear within sight of their homes. Why? Because rotational motion directly engages our instinctive perception. Environmental psychology studies suggest that humans often interpret asymmetric rotating objects as signals of danger or disorder. One- or two-blade turbines resemble swinging weapons, whereas three-blade turbines possess visual symmetry that the brain decodes as balance and safety. This sense of calm is not accidental. Three-point symmetry appears throughout nature, from flower petals and butterfly wings to molecular structures, and the human brain has evolved to favor such geometric stability. As a result, the three-blade design not only operates more smoothly, but also earns broader social acceptance. Once turbines became symbols of environmental responsibility, their aesthetics became inseparable from the politics of energy itself. From an economic perspective, each blade represents an investment asset. Removing one blade may cut material costs by 30%, yet it can increase maintenance expenses by more than 50%. Two-blade turbines, though cheaper to manufacture, experience stronger vibrations, causing shafts and bearings to wear out faster, turning maintenance into a long-term financial burden. In energy game theory, investors often view this as a Nash equilibrium. Everyone chooses the three-blade design because deviating from it introduces higher long-term risk. Even if initial costs seem lower, three blades create a balance between aerodynamic efficiency, stable power generation, maintenance costs, manageable wear, and social acceptance pleasing visuals. Lower noise. In industrial terms, this becomes a Pareto optimal design, one where improving a single factor inevitably worsens another. Once the three-blade standard emerged, wind energy evolved from experimental technology into a global business model, not only because it works in physics, but because it works in accounting. Entering the 21st century, the race for wind power became a race for height and scale. Denmark, home of Vestas, began with turbines around 40 meters tall. The United States pushed past 100 meters. China, within a decade, built blades longer than the wingspan of an Airbus, a 380, but as turbines grow larger, stability becomes a critical challenge. A blade stretching 120 meters endures wind forces equivalent to thousands of tons. Even a slight misalignment can cause the rotor to oscillate like a bridge in a storm. At such scales, only a three-blade configuration maintains a stable center of rotation. Two blades fail to distribute torque evenly, while four or more increase drag and inertia beyond safe limits. Thus, as the world competes for greater power output, the three-blade design has become an industrial genetic code shaping production lines, standardizing components, and defining control algorithms. Behind those giant white rotors lies an ecosystem of geopolitical power. The nations that master large blade technology hold a key to the future of clean energy. As development moves offshore, where winds are stronger and more consistent, the challenge shifts from generating electricity to coexisting with nature. Underwater noise can harm whales and dolphins. Turbines with many fast-spinning blades produce stronger acoustic waves, whereas 3 blades rotate more slowly while maintaining output, significantly reducing sonic impact. In salty, humid environments, material durability becomes a matter of survival. 3 blades allow engineers to balance thickness, weight, and rotational inertia, enabling turbines to withstand ocean storms without structural failure. When governments invest hundreds of billions of dollars into offshore wind farms, they are not merely purchasing equipment, they are buying social trust, a symbol of safety, balance, and sustainability. At the geopolitical level, wind is gradually replacing oil as a strategic asset, and the quiet, elegant silhouette of 3 blades has become the face of that new power. The shape of a turbine is not determined by physics alone, but by collective psychology and global economics. Humanity did not choose 3 blades because it is the perfect form, but because it is a peaceful compromise between efficiency and emotion. In the new energy world, beauty itself can become a mechanism of survival.